Well, again, in this lesson, we're going to be talking about the coordinate plane and ordered pairs. So it's always important to remember that it's x, y, so to the right or left, and then up and down. So the point 1, 4, over to the right 1, up 4, is the point F. Over 4 and up 1 is B. Easy to confuse those. Over 5 to the right and down 2 is G. That might be a little bit new. Over to the right 2 and down 1 is C. 0, 5, that's the point A. 8.5, 8 is L. H is 5, 4.2, and 0, 9 is E. Well, we can do the reverse too. I can give you the point, and you could try to give me the ordered pair that goes with it. M is 5 right, 7 up. N is 6 right, 0 up. Point P is 0 left and right, but 6 up. Point Q is 2 to the right, 3 up. Point R is 0, 3. Point S is negative 2, 3. Point T is negative 3, 2. Point U is 7 to the right and 5 up. And point V is negative 1. That means 1 to the left and 6 up. So here negative is meaning left, just like negative could also mean down. Let's dive deeper into the coordinate plane and relate it back to a number line. So we used to have a number line that went to the right, and we could count the numbers up. 1, 2, 3, 4, 5, 6, 7, 8. And we've recently added to the left, and we can count those numbers, and those numbers are decreasing to the left as they were on the right side as well. But these are our negative numbers. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Well, we're going to add another direction to this. We're now going to add a vertical axis along with our horizontal axis. So we're going to number up as positive, so 1, 2, 3, 4, 5, and down as negative, negative 1, negative 2, negative 3, negative 4, negative 5. So that's our coordinate plane as it kind of relates to a number line. Positive up, positive to right, negative left, negative down. So all these points are in reference to the origin, that's the center right there, and the origin is really where the x and y axes meet. We can describe that as the point 0, 0. To describe the location of points in the coordinate plane, we use ordered pairs. So they're ordered because the order is important. If we reverse them, it's different. We use the convention of x first, then y. The x is the location on the x-axis, and the y is the location on the y-axis. So let's go ahead and actually find some points that are just on the x-axis. So here we're just going to plot a couple points out here. I'm going to throw a few on the positive side and a few on the negative side. And the ordered pairs for these are 1, 0, and then this one is 5, 0. And then counting over, we're at 10, 0. And then this one is to the left, so that's negative 4, 0. 0 because it's not up or down at all. And this one is negative 11, 0, meaning it's 11 to the left, but not up or down. So what's in common between all these points? The y-coordinate is 0 in every single one of them. It's not up or down at all. So it's a little bit redundant, but the y-coordinate must be 0 for points on the x-axis. Let's do the same thing now with the y-axis, find some points on that. So throw a couple points on the positive side, a couple points on the negative side. So this point here is 0, 5, and this point up above it is 0, 9. 0 left and right, 5 up, and 9 up. This one is down below, so it's 0, negative 4, and 0, negative 7, and 0, negative 11. Down, but none left or right. So what can we say about points on the y-axis? We can say that the x-coordinates are all 0. So what must be true about all points on the y-axis is that their x-coordinates must be 0. Now, if the origin is the only point for both, with 0 for both coordinates, what must be true about it? The x and y coordinates must be true about, must be 0 for that point. Okay, so let's talk more about the setup of the quadrants. We have actually broken our coordinate plane into 4 pieces with our axes. So the first one that we're most familiar with is in the upper right-hand corner, and that quadrant is quadrant 1. We use a Roman numeral. We go counterclockwise, and the next quadrant is 2, then 3, and then 4. It is important that we use Roman numerals to name them. That's the convention. And that when we're counting, we start in the upper right and we go counterclockwise. So let's look at a few points here. Let's go ahead and plot them, and then we can see which quadrant they're falling in. 7, 2 is to the right 7, and up 2, and that's going to be in quadrant 1. 3, negative 4 is 3 to the right and 4 down. That's going to be in quadrant 4. 1, negative 5, 1 right, 5 down. That is also in quadrant 4. Negative 3, 8 is 3 to the left and up 8, so that's going to be quadrant 2. Negative 2, negative 1 is 2 to the left and 1 down, so that's going to be quadrant 3. So if we asked you to pick some points that were in each of the 4 quadrants, let's pick a point in the first quadrant. I'm going to go ahead and pick 2, 2, and I'll explain why. I'm going to kind of keep these kind of basic. I'm going to make quadrant 2 a point negative 2, 2, quadrant 3, negative 2, negative 2, and quadrant 4, 2, negative 2. That might help you see the pattern a little bit more easily by me picking those numbers. You might notice, and here I'll draw kind of a visual explanation, in the first quadrant, both coordinates are positive. In the second quadrant, it's negative then positive. In the third quadrant, negative then negative. In the fourth quadrant, positive then negative. And that's always the way that those will go.